Hello everyone, I am your instructor, Wang Shengda. Today, we will learn about the composition and constitution of polymer chains. Through this lesson, you will master the elemental composition of 4 common polymer chains. You will also understand how elemental composition affects polymer properties and applications. You will gain the ability to analyze the structure and properties of polymer chains. And you will be able to clearly explain concepts related to polymer chain structure and properties. First, let's learn what a polymer chain is. Polymers are also made up of molecules. Because common polymers have shapes in space similar to chains. The molecules that make up polymer materials are called polymer chains. These are chain-like molecules formed by monomers linked through polymerization reactions. Most polymers are made up of carbon and hydrogen elements. A significant portion also contains oxygen, nitrogen, sulfur, and other elements. Based on the composition of the main chain elements in polymers. Polymers can be roughly divided into carbon chain polymers, heterochain polymers, elemental organic polymers, and inorganic polymers. The main chain of carbon chain polymers is made entirely of carbon atoms, and they are mostly produced through addition polymerization reactions. For example, polyethylene used to make plastic bags, polypropylene used for making sheets, polystyrene used to make foam plastics, and polyvinyl chloride used for waterproof membranes. Carbon chain polymers generally have good plasticity, are easy to process and shape, are not easily hydrolyzed, and have low costs. They are usually used as general-purpose plastics. But they also have drawbacks like low mechanical strength, flammability, poor heat resistance, and easy aging. In the main chain of heterochain polymers, besides carbon atoms, there are also atoms like nitrogen, oxygen, and sulfur. They are mostly made by condensation and ring-opening polymerization reactions. For example, nylon 66 used for making structural parts. Polycarbonate used for making airplane windows. Because heterochain polymers have nitrogen, oxygen, sulfur atoms in their main chain. The intermolecular forces in heterochain polymers are stronger than those in carbon chain polymers. Therefore, heterochain polymers have higher mechanical strength and heat resistance than carbon chain polymers. They are generally used as engineering plastics. This is also due to the presence of heteroatoms. Heterochain polymers have a more polar main chain compared to carbon chain polymers. This makes heterochain polymers more susceptible to hydrolysis or acidolysis, resulting in the drawbacks of being water-sensitive or acid-sensitive. The main chain of elemental organic polymers contains no carbon atoms. It is composed of non-carbon atoms such as silicon, boron, aluminum, titanium, oxygen, nitrogen, sulfur, and phosphorus. However, the side groups are carbon-containing organic substituents. For example, polydimethylsiloxane. It is also known as silicone rubber. It is used to make sealants, molds, casings, protective covers, and other components. The advantage of element organic polymers is that they combine the heat resistance of inorganic materials with the elasticity and plasticity of organic materials. The drawbacks are high synthesis costs and relatively low mechanical strength. The main chain and side groups of inorganic polymers contain no carbon atoms. They are entirely made up of other elements. For example, polyphenoxy orthohydroxy groups. They are used as flame retardants. The advantage of inorganic polymers is their high temperature resistance. Their drawbacks include weak bonding ability, low strength, and susceptibility to hydrolysis. Additionally, there are some polymers that don't fit into the first 4 categories, such as ladder polymers. When exposed to heat, At least two chemical bonds must break within the same ladder unit for a significant drop in polymer chain molecular weight to occur. Therefore, these polymers have relatively good thermal stability. Finally, we study the effect of end groups on the properties of polymer materials. Taking polyoxymethylene as an example, if we ignore the end groups, its structural formula is shown in the first diagram. If the end groups are considered, its structural formula is shown in the second structure. We can see that, of the two end groups in polyoxymethylene, one has a structure and composition different from the repeating unit. In fact, in most cases, the end groups of polymer chains differ from the structure of the repeating unit. The polymer's end groups mainly affect its thermal stability, because degradation of many molecular chains starts from the end groups. Unstable end groups can be converted into stable ones through specific reactions. This improves the thermal stability of the polymer. In this lesson, we studied the classification of polymers based on their elemental composition. These include carbon chain polymers, heterochain polymers, elemental organic polymers, and inorganic polymers. We need to understand that the elemental composition decisively affects the properties and uses of polymers.